Hi guys. We are going to do the back of your 1.4 notes right now because I ran out of time when the bell rang. So we already talked about what our solutions will look like. We could have infinite solutions, we could have one solution, or we could have no solution where we have got our parallel lines. So if you need that part of the notes, then watch the front video. This is going to be the back. All right, so here's the back. We have a word problem. We want to know how many additional meals are needed for the cost of the two plans to be the same. I see the question, how many additional meals? I already know that has to give me my let statement. X has got to be the additional meals. Okay, we can always get the let statement from the question because the question tells us what we're trying to figure out, the unknown, and the variable represents the unknown. Ta-da! Okay, now let's look for some key words. We want the costs to be the same, so I know that I need an equation. Okay, I see the word each. That tells me that this 8 and this 3 are the ones that get the x. Okay, so I want the silver and the gold plan to have the same cost. So I'm going to make a silver side of my equation and a gold side. And I want those to be the same. So for my silver plan, it's going to be $200 for the base price, which includes 100 meals. And then it's going to be $8 more for every additional meal. For my gold, it's going to be $300 for the base price and then $3 for each additional meal. Now we just have to solve and write a sentence. So let's get all of the x's over on one side so that we can divide by the coefficient of x eventually and find out what x is. So if we subtract 3x from both sides, these cancel. I get 200 plus 5x equals 300. Okay, I don't want 200 over there on the left with the x's. It's a constant. I'm going to subtract 200 from both sides. The 200 and the negative 200 cancel, and I get 5x equals 100. Okay, when I divide both sides by 5, I get x equals 20. So the last thing I need is to write a sentence. Before we do that, I want to show you something to give you a visual of what is happening because I think it's important. So I'm going to make a little table. You're welcome to make the table with me, or you can just watch this like dinner theater. Nope, we're not going to do that. Maybe another time. Okay, so we're just going to write the sentence. So at 20 additional meals, the plans will cost the same amount of money. Ta-da! Sentence. Cool. All right, let's talk about these. These are so important they could almost get their own video. In fact, in other years, they have had their own video. So if you thought you were just going to zip through this part, let this marinate. This is really important stuff here. Okay, so we have to solve each equation for y and justify our steps. Okay, so what you're probably noticing is that instead of just numbers in here with x, we also have some y's. So we're going to get the y's alone, and all of the other stuff has to be on the other side of the equation. So I have a positive 2x on the left with my y, and I don't want it there. I want the y alone. So I'm going to have to subtract 2x from both sides. Okay, that gives me y, these cancel, equals a 10 minus a 2x. And then I stop, because 10 and 2x are not like terms. Okay, I just write them next to each other, subtracting, but I cannot combine them. They do not combine. Okay, so we stop and do not combine. Okay, so the thing that allows me to subtract 2x from both sides is the subtraction property of equality. Okay, now, and we're done. It was just that one step. All we had to do was subtract 2x from both sides. All right, look at the next one. This one doesn't have x's on the left with the y, but it has a 3, okay? The 3 is the coefficient of y, but we want the y to just be there alone. So we have got to undo the multiplying that's happening between the 3 and the y. So we're going to lock the y in place. It's not going to move. Locked. We're going to divide this side by 3, and then we're going to divide this whole side by 3. Okay, 3 over 3 is 1. 1y is just y. Now, when I'm dividing on the right, I have to make sure that I divide both terms by 3 because the whole side is divided by 3. So the 6x gets divided by 3 and turns into 2x. The 12 gets divided by 3 and turns into a 4. Now it looks kind of like my other one. I'm done. I stop. There's nothing else to do. That was the division property of equality. Okay. All right, look at the last one. Notice that like the first one we did, it's got x's in the front. X is over there with the y. And like the second one we did, it's got a coefficient in front of the variable y. So I'm going to have to do the same kind of thing I did here and the same kind of thing I did on the second problem. So the third problem is kind of like a smash up of the first two. Okay, here we go. So the first thing I'm going to do is get rid of that negative 4x. Okay, so I undo subtracting 4x by adding 4x to both sides. Okay, these cancel, they make 0. Okay, and I've got 2y equals 8 plus 4x. That was the addition property of equality. Okay, the next thing I have to do is get rid of the variable 2 that's being, the coefficient 2 that's being multiplied with my variable y. So I have to divide them apart. So I'm going to divide both sides by 2. The 2's cancel to make a 1. So I get y equals, now I divide the 8 by 2 and get 4, and I divide the 4x by 2 and I get plus 2x. Okay, that was the division property of equality. Okay, that's a wrap. That's it.